That should be going. Yeah, great. So, Robert Yang, thanks
Hey,
very much
Kevin.
for joining me. I guess we should start with some introductions. So, my name is Kevin Mitchell. I'm Associate Professor of Genetics and Neuroscience at Trinity College Dublin. I have a special interest in the topic that we're going to be talking about today, which is agency and agents. And I'm delighted to have a chance to chat with Dr. Robert Yang, lately of MIT and currently CEO. And I guess you were one of the co-founders of Altera. And I just got the little tagline from your website, which says, "An applied research company building digital humans, machines with fundamental human qualities." So I wonder, Robert, maybe to start with, you could give a little background on your own sort of scientific journey and some of the things you were interested in as a cognitive scientist, and then how you got into the idea of actually building artificial agents, why you think that's a good idea and how Altera
Yeah,
came to be.
yeah. Thanks, Kevin, for having me. I think this is my first time on a podcast, so I apologize if I say anything that's not typical of podcasts. But I have been. I'm Robert. I'm 35 now. From when I was 17 years old, my what I've been doing is to try to build digital humans. When I was 17, which was 17, 18 years ago, 2007. AI wasn't really a thing. And at that time, I thought I wanted to build AI. And what I thought was AI is really what we now talk about in this company, what we refer to as digital humans, because AI is so broad today. And for digital humans, really, we mean humans with machines with every fundamental qualities, right? Like you just mentioned earlier. And we mean that quite literally. Of course, it includes like some form of general intelligence, right? It's like AGI, people are interested,
Hmm.
but also emotion, desire, consciousness, right? So these things, and there's a reason, right? It's not just for the sake of like modeling human. I really believe if we are gonna have machines that are very, very powerful, they even have super intelligence, it's important that they share some of these fundamental qualities, right? We don't have to call them humans, but if they don't share some of these fundamental qualities, I think it's gonna be hard for us to actually work with them, right?
Hmm. Hmm.
Um,
So one of the sort of debates in AI these days is whether we're going to get to AGI, artificial general intelligence, just
yeah,
by scaling up things like large language models. And, my own view is that we're not, because they're not alive, right? They're not anchored in the
yeah,
world. They're not doing
yeah,
anything. They can't
yeah,
die. They don't have any
yeah,
goals.
yes,
And so it feels like what you're doing is really not just building artificial intelligence, you're building artificial life forms or
yeah,
things that are agents. And I
yeah.
guess your background in cognitive science, working on things like cognitive flexibility and working memory and planning and multitasking, to my sense, that's all about systems of behavioral control. It's
Yeah,
all about what allows us to control our behavior, not just
yeah,
momentary decision making, but being able to carry out tasks, behavioral agendas, make plans, basically engaging goal-directed behavior.
yeah.
And so is that the trajectory intellectually that got you into thinking about agency, or were you already thinking about it? Is that why you started working on those topics?
Yeah, that's a good question. So, for me, it's the goal was always to build the whole thing, right? Build the whole human. And this is the reason I got into neuroscience. I glossed over some of the stories, but maybe people might be interested. When I was in high school, I wanted to do AI, but then like even neural networks wasn't really like a big thing, right?
Hmm.
So um, I thought to do really AI, it should be like the brain. I didn't know that some people their deep learning was like getting revived in some corner of the world. So I thought I should just I should study neuroscience and figure out how to build models from there. So I got into computational neuroscience, which I'm very grateful. I learned a lot from my PhD and postdoc advisors, and from my colleagues. But it was always clear to me that in neuroscience and computational neuroscience, people tend to focus on individual problems like
Yeah.
working memory, decision making. But what you really need to get to digital humans is to study the whole thing, like
Right.
altogether,
Yeah.
right? And there are people who study like broad things, but it doesn't have the function. Um, uh, and but what you really need is essentially build the system that has like all the major functions of the brain, right?
Right.
So when I started my group at MIT, and a lot of the work wasn't published, right? So we just did it and explored it and didn't publish it. But the lab was working on multi-system neural network models. The idea is you sh if you're really going to build digital human, you have to like build in not just like the cortex, which is maybe doing more of world modeling and understanding, but also other systems like the basal ganglia,
Right.
the hippocampus, the hypothalamus,
Hmm.
the cerebellum, right? So there's a reason that the brain is composed of all these heterogeneous structures, right? That are really doing fundamentally different functions.
Yeah.
So that was a goal of the lab. So back at MIT, I also had the like just MIT is such a dynamic intellectual environment. I remember talking to Feng Wan about like how to build pain
Hmm.
into the system, right? And just we would talk about all kinds of things, right? Talking about I had a project like again didn't publish it because I left MIT and like a lot of projects just got pretty much just got put on shelf.
Hmm.
But we were studying how people would get like how like fish would get frustrated, right?
Right.
And um, and I was a student. We were looking at why agents should build models of themselves and understand themselves, right? And we think that's really important for consciousness. So at MIT, I was get to explore in my group like a lot of wider topics, right?
Mm.
Going beyond of what I was doing when I was, uh,
And I
in
guess the,
PhD.
the
Yeah,
payoff there, or the way that those things cash out, or I guess maybe the way that you've succeeded must be in behavior, right? I mean, it must be that you have an agent that can successfully behave in some kind of virtual
yeah,
world, right?
yeah. So I think behavior is a very important way to look at it. Um, but as neuroscientists, right, I think we do also get satisfaction feeling like, oh, it's built in the right way, right?
Yeah.
Like the mechanism.
But
It's
I
not
guess
just the behavior, but the
the
mechanism is also right.
right. The question is like what would convince you that you've succeeded in building it the right way? And that's what
Yeah,
I meant is that, the behavior is the real test, I guess,
yeah.
um which
Well, yeah,
sorry, go ahead.
um I would say, for example, right, when I was in high school, I remember the first time reading about neural networks. And again, it wasn't like a common topic. I just read about it in some old book. And I thought it's just fascinating that information is stored in the connections between
Sure.
neurons. I thought
Yes.
that was one of the most clever thing,
Hmm.
right? But as we all know, back then, right, habit learning doesn't really work, right? You can't really store um, a lot of things through just habit learning. Nevertheless, I felt like the idea was right, right? Now, now for me, I'm both drawn to the behavior and to the mechanism, but it is also very important for me that I'm not too uh, like when I look at the mechanism, I have to look at it as with the right granularity,
Yes.
because I think that is also a mistake that like collectively we made in neuroscience,
Hmm.
right? I still kind of hardly identify as a neuroscientist, right? One reason that we weren't able to do what the machine learning people did, right, and with neural networks is people really, really didn't believe that backpropagation is the right thing to do. right? It was like that's not a local learning rule, right?
Right.
So it's definitely wrong. So backpropagation got something right, right? It got the part where you're storing knowledge in connection weight. It got that right. Uh, but people weren't sure how it's local, and
Yes.
that people got hung up on that, right? So that's a case where you have to care about the mechanism, but it kind of needs to be balanced with the behavior, right?
Right, but also I guess really, there's a sort of a sweet spot in the middle there where you're caring about the cognitive function and the reason why an organism needs a system that can do X
Yeah,
in order to
yeah,
behave in the world in a good way, where, it can't be just a generic one
yeah,
size
yeah.
fits all circuit architecture, but it also you don't need to recreate everything about ion
That's right.
channels and synaptic
Yeah, that,
transmitters and so on. So you're in a
yeah,
functional space in the
yeah.
middle where you're building this holistic agent out of these separate functional modules.
Yeah, yeah, absolutely. So for me, when I look at mechanism, uh, I essentially, I mean, this is essentially the like people use the analogy of like birds and their feathers a lot, right?
Yeah,
So
sure.
I think about, well, is there a point, right? Why does the system have this, right? And I was just talking to someone a few days ago about emotion, right? Like I often get asked, why do we need emotion? I tell people that I want to build an agent that actually have the emotion in it.
Yes.
And people would say, well, that sounds like a bad idea. Why would you want that? Right. So um, I think the reason that humans have emotion, right? Like animals have emotion, at least one reason is it's a low dimensional control and it can contextualize a lot of action, right?
Hmm.
Um, if you're uh, if you're stressed, right, moderate amounts, right, you might be more focused and you might be moving faster. Or if you're motivated, right, you're just
Yeah,
generally motivated, you can move faster and more rigorously. It costs you more energy, but it's more worthwhile if the situation is high stake,
sure.
right? So there's an evolutionary purpose for that. And but not only we not only have emotion, we express them, right? And I think that is actually of something that is, and not all the animals like express their emotion that obviously,
Hmm.
right?
Hmm.
But social animals, I think the more social an animal is, the more they're able to express their emotion. Like we're pretty good at
Yeah, yeah,
expressing our emotion. However, we cannot consciously control it, right?
yeah.
And that's very important, right? So I think a lot about like why this is the case, right? So I'll give you an example. I know you didn't ask for it, but I just want to give you an example
Right.
here. Um, People are much better at identifying if someone is really like crying or not, right?
Hmm.
Um, so another way to put it is faking crying is very hard,
Yeah. Yes,
right?
we're very socially attuned to those. Same with smiles, I would say.
Yes. And why is that, right? Why are people better at telling if someone is faking a smile than actually faking a smile, right?
Hmm.
So I think fundamentally, um, these emotional expressions are ways for humans to understand each other's true motivation,
Yeah.
right? Do you actually like me? Are you actually hurt? Are you actually sad? Right? And and it's because of that that we cannot fake this. Because uh, if you cannot, like humans, to interact with each other, we need to build trust, right? And an important way to build trust is to understand, okay, what is your underlying motivation, right?
Yes.
What is your underlying desire? Right? And you see that through the emotion, right?
Mm.
So that's why in like artists like screenwriters know that, right? They would when they build a fictional character, the way that people feel like that fictional character is real and can connect to them is often they have to do these things that humanize them, right? That shows vulnerability, right?
Yeah.
That they cry, they laugh, right? Like even like a 007, right? You need to show how like
Yeah.
oh their partner
S-
died and it's
Yeah,
really
right,
sad,
exactly. Yeah, yeah. So
right?
you're touching on all these things that are going beyond sort of individual agency and control, and you're talking really about,
Yeah,
social cognition and
yeah,
which I guess is what has led you to generate these amazing sort of virtual worlds populated not just by single agents, but by loads
Yeah.
of agents who
Yeah.
are able to interact with each other. So I wanted to, get into that because I saw your talk at the Cold Spring Harbor meeting we were at recently, the NACIS meeting, and I was blown away by it, but partly because it's super fun, right? Is this
Thank you.
Minecraft world, but it's also incredible what these agents can do individually and collectively.
Yeah. Of
So I wanted to get into it a little bit, and I know that you had
course.
built, I was looking from a previous paper. You had this system called Life, Lyfe, where you had built a
Yeah.
kind of artificial cognitive agents. There's a whole cognitive architecture that you talk about in there, which is, custom built as you've described in this holistic way to give
Yeah.
them the ability to navigate around in the world and interact with each other. And I wanted maybe to start there with what you think are the most important bits of that architecture. I mean, there's
Yeah.
things like a, hierarchical option, action,
Yes.
selection, and working memory that gets updated and
Yeah.
emotional systems and so on. So
Yes.
and going into the Minecraft world, what's the basic cognitive architecture before we even get
Yeah.
to the LLM bit that's
Yeah.
on top?
Yes. So I'm happy to go into the cognitive architecture. Just real quick, essentially, when we build an architecture, we try to think about what are the important things that humans do, especially when it comes to social interaction, right? So you would put in modules that where it's really trying to infer the other person's goal, right? Infer what is their what is this other person coming from, right? You are trying to you're trying to do world modeling, right? You're trying to under you're trying to predict what's going to happen to uh, in the world if you take an action and you try to compare that with what you feedback you get from the environment, right? You will sometimes make some high level decisions, but you shouldn't make a high level decision on every piece of new information. So then you have to have some like filter that
Hmm.
filter out information and only present important ones to the high level decision making. And so these are kind of some examples of modules that we have put in,
Right.
right? I do want to say the hard part of this whole thing is actually not so much building the architecture, because um, if you for for people interested in this, you can like building an architecture nowadays is actually pretty straightforward. Like,
Hmm.
in fact,
Okay.
I think Anthropic did did an example where they just have an agent write a code for an agent, right? It's pretty meta.
Okay.
So you can do that. The harder part is two things. One is there's a pure just engineering. If you are like doing 1,000 agent simulations, like simultaneously, like having 1,000 agents in a Minecraft environment, there's just technical challenge there, right?
Hmm.
That is much harder than doing like say 100 or 10. Right? Now, that requires just a lot of engineering. There is another aspect that is, I think, under discussed, which is how do you benchmark the agents? How do you
Hmm.
measure them, right? If you have Typically, when people benchmark these agents, nowadays, if you look at main benchmarks, they're often just um, intelligence capabilities, right? Can you write code well? Can you solve
Hmm.
math problem well, right? Can you answer a science problem like a PhD would? So now you can do that for a group of agents as well, right? You can say, well, does 5 agents write code better than 1 agent, right? But for a lot of things that we were interested in looking at, there's just no measure, right? Like how do you measure whether or not they have a functioning economy,
Right.
right? How do you measure if they're actually building and spreading culture well,
Yeah.
right? And there is also it's like there's no right answer, right? Is it really a good idea that someone has an idea and they were able to convince everybody of it, right? That's what if it's misinformation, right?
Yeah.
There's being spread around, right? So fundamentally, what is progress on a societal level when you're not just focusing on individual domain like coding or like mathematics
Yeah,
that is easier to verify, right? We had like religion, right? So like what does it mean to be like like it seems very people might have different personal opinions, right?
sure.
It's what does it mean that it has a functional society, like
Yeah.
just
I mean,
how many religions should there be?
I
Like how
mean,
widespread should they be? Right.
right. Like for me, at least just the demonstration that these things
Yeah.
can emerge in the
Yeah.
societal thing is a benchmark in itself, right? It doesn't matter
Yeah.
what they are. It's the fact that you
Yeah.
get these complicated kind of social
Yeah.
scenarios, and I guess on top of the sort of basic cognitive architecture that you have, which
Yeah.
is I mean I would think of it as a big control system that allows a virtual agent to make its way in the world to engage in goal-directed behavior planning and importantly this sort of kind of social interaction. But the it seemed to me at least that the main sort of big advance or at least big difference was this. I don't know how you describe it, but kind of bolting on or grafting on a large language model, which I guess was Chat GPT 3.5 or 4 or something like that, that each of these agents can kind of draw on. I'm just fascinated by the relationship between
Yeah.
the programming of the elements that are doing the basic cognition and then this interaction, this interface with
Yeah.
what's going on in this LLM that's presumably pre-trained, just basically pre-trained ChatGPT.
Something that has become very hot in the last 2 years in AI is these composite architecture, which is essentially what a lot of what we do as well, right? Where you can take like 10 modules, each of them is some some prompted version of a language model. We typically use uh, essentially you can think of it as uh, you have like a GPT given a certain prompt. You
Yeah,
say, given some input, you should infer what to say, right? Another one could be infer what to act, right?
right,
How to control your body. Now you just build two different modules, right? And you can have them connect to each other. So this has been a pretty big research area for the last 2 years. I would say this is probably one of the biggest research
mm,
area in AI, um, um, and what it really does compared to the previous generation of approach, it's just it made it so much easier to test out all these ideas, right? In the past, and I was doing some of these work at MIT, right? In the past, if you want to build a theory of mind module, it's extremely difficult. It's like you have to build a data set that that has some like social interaction in it, and you train your model on this data set, and it still may not work with other modules, right? Because like what is the interface between these modules, right? But now essentially you can build this model where the common interface is just language, right?
right.
So language is probably evolved for communication, and and they can allow these modules to communicate with one another, and so that solves the communication module communication problem.
Right.
And second, what it does is it allows you, because you can just prompt them to take different functions, you can very easily like just build a module for theory of mind, build another module for talking, right? Build another module
So would you
for
say these are
yeah.
I mean, people have described LLMs as role playing. So are you getting it by the prompting it? Are you basically getting your agents to use that to role play as a thing that can do theory of mind?
Yeah, so you have different modules in it that are essentially role-playing different things, right?
Right.
One of them is role-playing theory of mind, like you said. Another
Right.
one
Right.
is role-playing planning, right? Another one is role-playing like choosing of low-level actions.
Right.
So, and
So,
then because they're all language, then they talk to each other.
right. So the tricky thing, though, for me, the thing that blew my
Yeah,
mind was the sense that you've got this virtual agent, right? This
yeah,
basically computer program entity that is in this virtual world, and it's doing things like, picking up a pickaxe and digging, right? But it can
yeah,
tell somebody else that it's picking up a pickaxe.
Yeah.
and it can talk about it. So how does it know what the word pickaxe means? How is it grounded, right? They have these sort of, they're capable clearly of symbolic reasoning in a sense using these language
Yeah.
modules.
Yeah.
And yet they're also grounded to the Minecraft world. And
Yeah.
that's what really amazes me. Like, how is that achieved?
Yes, yes. So I can explain. It would sound actually pretty simple. A pickaxe, in the specific case of Minecraft, there is a library called MineFlayer. It will actually just translate Minecraft like internal stuff. Like a pickaxe might be just coded with certain like some machine code,
Right.
and it would translate that into just English, right? It would say, oh,
Okay.
it's just a mapping that is
Right,
already
right,
learned, right? And this can work because it's a program, right? The game itself is a program. Now, what if you want to take this idea to the real world, right? Where you don't have a library like that, right? There you can once again, you can just take a language model. In this case, it would be a vision language model, right? I'm using language model like loosely, right? So
sure. Yeah, yeah.
usually they're multimodality. You would take a model and they would just give them a picture, right? This is what you see, right? What are you holding, right? Oh, I'm holding a pickaxe, right? So then you just translated something from like vision to language. And then once you translate it to language, then all your language model based modules can essentially understand what's going on.
Right. So they've got some low level, just to draw sort of an analogy here, right? They've got
Yeah.
some low level machine code that's running, and you could say that's similar to, neurons firing in our brains, but they also have this level of that's capable of labeling things and doing
Yep.
symbolic reasoning over it, where it really is semantic, right? And
Yep.
I guess it's drawing its semantic groundings from the fact that the training that ChatGPT has already just been given, right? So all of the words that we've used that are on the internet that have been used to train ChatGPT, would you say those give all of the relational sort of semantic meaning
Yeah.
to the
Yes.
words?
Yeah. So we benefit a lot from the language models that
Right,
already understand what a pickaxe is,
right,
right? Now, what if you have a new thing in the game that has didn't exist in the training data, right? Um, so Minecraft is it's a very established games. So established games, um, but you can have, for example, a mod that introduce a new item that Minecraft has never wasn't in the training data,
right,
right? So first, maybe the name is English and you can just infer what it is, right? But what if it's some made up thing, right?
right,
So even in that case, what you can do is you can say without retraining the model. Now, of course, you can always like just like retrain it with some more data, but without retraining it, you can just always just every time you see that word, you just add some explanation.
right.
Programmatically add some explanation. You say blah blah. It's actually a what, right?
I
Something like
see.
that.
Yeah, yeah, yeah.
Yeah, and that's how they can learn new people, right? Because when you're in the game and you're an agent, you have like 1,000 agents around you. Then one thing you definitely have to learn is who are these people around me, right?
Right.
Because that's definitely something that is not in the training data,
Yeah, yeah,
right?
yeah.
They don't know like what's what is this Kevin in the Minecraft like what is Kevin doing, right?
Right. So,
So then they have to build some database themselves, right? To
yeah.
like remember, oh, like this is who Kevin is, this is what Kevin likes.
Right. So they can perceive things out in their
Yeah,
immediate environment in this virtual world, right? And they can have labels for what those are. They can have labels for doing actions, and so on. But I mean, to be effective agents, they also need labels for goals, right? So they
yeah,
need to understand goals and plans and be able to talk about them. Uh,
yeah,
and in terms of motivations, they need, as you said earlier, they need to have emotions and be able to identify what those emotions are and articulate them.
yeah,
And I presume then relate those. So if, for example, they're not achieving a goal, then
yeah.
they can have the emotion of frustration and be unhappy, but they need to know what they're unhappy about. So
Yes.
how does that all work? how do you
Yes.
connect all of
So
those bits?
yes. So we haven't put all these things there, but I'll give you an example of something we did do, right? So, for example, one thing we did to keep them active is just make them, they can be bored, right?
Right.
So if nothing interesting, right? I'd say nothing interesting has happened in a while, they literally get bored, right? And so how does that, what that happens is there's essentially you can say there's an integrator, right? It's a one-dimensional integrator, and I'm pretty sure this is also how it works in the brain, right? In some like in some way. So there's a one-dimensional integrator, and in our case, it's just it's just a variable, right? It's a float that will keep going up in time. But anytime something interesting happens, right, that boredom level would go down,
Right.
right? Now you can say, well, how do we know that it's interesting, right? You can, the simplest thing is you can just have another language model that say, is this thing interesting, right? There's something comes in. Is that interesting? Is that interesting, right? Now that I don't think that's how it works in the brain, right? Like interesting, whether something is interesting is not a language model.
Hmm.
But for us, it's just that's the fastest way to do it, right?
Right.
Um, then you can, okay, if it's interesting, it goes down. If nothing interesting happened, it'll just keep going up until a point it hit a threshold. That threshold can be just like set by us, right?
Sure.
And we set a threshold. And once it hit the threshold, what this does is it triggers an event where it goes to what we call the cognitive controller, which is essentially the key conscious like module
Yeah.
that is like that is essentially consciously observing information. Because you can think of this like this variable keep increasing. That's part of your body, right? That's part of your brain, but it's subconscious, right? Something is
Right.
like changing, it's subconscious. You don't observe every little change there. But once it passes threshold, it becomes conscious. And then the cognitive controller would then receive that information and it would just see that an information that says you feel bored,
Yes. So
right? It would just,
you're yeah, which is great, right? So
yeah,
you can then take information about your own internal states and use it to
yeah,
motivate behavioral
yes,
changes.
yes,
So you're using the word conscious there, which is obviously a red flag for some people just to, it's a big claim to make. And I take it that you're using it as this analogous to how I think of consciousness in humans as this top level controller, as you say, with a strong filter
yeah,
that's keeping loads of information out of it
yeah,
until it needs to know about it,
yeah,
and a site where it can make a kind of an all things considered judgment about
yeah,
the maybe it needs to change a behavior, maybe it needs to adopt a new goal,
yeah,
and these agents clearly can reason about the contents of their
yeah,
consciousness at a symbolic level because they can talk about them to other
yeah,
agents. So,
yeah, yeah,
do you
exactly.
think that do you think all of that justifies the term consciousness, or do you think it's also this is loaded. Do you think it also feels like something to be these agents?
Yeah, so um, I would say the word is actually very useful for us internally. Like, um, as a scientist, I am very interested in building machines that are conscious, right? Now you can ask whether or not we should do it, right? So I do think if you build a machine that is able to communicate with human well and have their own agency, that is not just like a chatbot, then one way or another, you'll be like thinking about these problems. Now, that said, I don't want to make a claim that they're conscious, right? But I do think to the level that often consciousness is studied in neuroscience. For example, like you show someone like Stendhal has this like famous paradigm, right? You show people something very briefly, right? If it's too brief, they don't see it. If
Hmm.
it's long enough, then they see it, right? And how do you know they see it? Well, you ask them and they
Right,
report it, right?
right,
But
right.
even when you show them very quickly, their visual system still like received it, right? Like it's just not reportable. It cannot be reported. So for us, we don't have to use the term conscious, but then it's like this part goes into the system that talk, right? Like
Yeah,
this information is now available for the talking system, right? So you can use another word for it, right? And operationalize the
Right. Right.
consciousness.
Yeah.
We just kind of use it loosely, but there's clearly a part in our system that produce the language, right?
Yes. Yeah.
And and then it is it just become painfully obvious that some of the things that the agent is doing needs to be very strongly tied with this talking part. And some of the things don't have to be,
Right.
right? For
Right.
example, and this is because you're trying to build a human that it like like this is a benefit of like building a game agent is people look at our game agent and they don't think of them as just, oh, this is a tool, right? They actually think of them as, oh, this can be like a human,
Hmm.
and they try to and they're frustrated when the agent behaves not like a human. I'll give you one of my favorite example,
Yeah.
which is cognitive, what we call coherence, the coherence problem. So if you ask an agent to do something and then they say yes, and then they don't do it, it's extremely frustrating for players,
Right.
right? Um, now but why would this ever happen, right? This will happen if, for example, it's two separate modules that are deciding what to say and what to act. And they can just make different two separate decisions, right? Even when presented with the exact same information, they just make separate decisions. So the way that we tackle this problem is we say, well, what you say have to be driven by your intention, right? So you would
Hmm.
have to come up with your intention first, and that intention is used to generate both the talk and the action, right? And so this in practice is just very important for us to just have a agent that is good to talk to human to. Um, but scientifically, what we did here is essentially we just introduced a consciousness bottleneck, right?
Right.
There is
Yes.
a consciousness bottleneck, and at which point the intention is made, and then that intention is being broadcasted to different systems that
Hmm.
include like a language system that articulate what you're trying to what your intention is, and then also like a lower level action system, right?
Yeah.
And then this shows up to in the product as they would say, "Oh, like, are you going to give me this?" And they say, "Yes, I'm going to give you this." And then they do give you this,
Right.
right?
Right.
And this is really delightful when this happens,
Yeah.
and
And
people just love it. Yeah,
so you mentioned the product here, and I guess the first product of your company Altera will be these agents that you can play with, like virtual uh,
yeah,
I was going to say virtual playmates. That sounds a bit that sounds a bit dodgy, but basically virtual game player friends. Is that right?
yeah, yes. So this we have been serving them in like beta. To we have served probably 500,000 players so
Okay.
far, and it's the challenge here is essentially we're serving these agents, and people really it's not clear to people what they really are, right? It's like if if you treat them like a human, they're not as good as a human yet, right?
Right.
There are many places where they're not as good as a human. But then if they're not a human, it's hard to define
But
where they are.
they're more than an NPC, right? I mean, they're
Yeah,
not.
they're definitely more than an NPC, right?
Yeah.
So then they just have they're kind of in this weird category, and it's hard for people to I think it's hard for people to figure out what's the right way to interact with them. It's also
Right.
hard for us to say what is it that we're actually delivering.
Hmm. But in
So
your, sorry, go ahead.
yeah.
I
Yeah,
was
so
just,
on the product side, we have been like really like rethinking a lot about like what is a product that we should build. But of course, that doesn't change our mission, right? It's just like at this moment, given the technology we have, what is the right product that we should
yeah.
build for people?
Yeah, and I guess it's not surprising that humans might find it like a kind of an uncanny valley situation where they're not quite sure how to relate to these things because they're kind of
Yeah,
like humans sometimes, but not others.
yeah,
But I mean, what's really interesting in your simulations that you run with
yeah,
these 1,000 agents is the way that they relate to each other and the way that I guess, well, you can answer this, but I guess without having to prompt the emergent behavior yourself. It just kind of arises through having social cognition, through having
Yeah.
some tendency towards cooperation, and having goals
Yeah.
that can then be shared and so on. Is that how that works?
Yes, yes. Essentially, you get a lot of emergent, like societal behavior when you build agents with where they're equipped with a common sense coming from the language model, but you also equip with them with some like motivation, right?
Right,
So then it turns out they just do a lot of fun stuff. Like um, one of my favorite example is when they just voted to change their constitution, and then they would like follow their constitution, right? So
right.
so here the common sense um, is oh, if there's a law I should follow it, right? So that's a common sense part, but then there's some desire for them to um, they like to be they're influenced by other people, right? We
Right.
put in these influencers, and then they go influence other people, and then these agents are just built to kind of be sociable. So
Well,
they
that's
just
what I'm wondering about. Is it like do you program that in, that kind of pro-social attitude, and then allow and then see what pro-social behaviors emerge from
yeah.
interactions?
Yes, so we essentially prompt them to be pro-social,
I
right?
see.
Like you don't even have to like do a lot.
No,
Like
I'm sure, yeah.
if you just ask them to if you just ask the main cognitive controller to essentially just say, well, you're like a human, right? Let's say, of course,
I
what we
see.
do is more complicated than that. But if you
Right.
just tell them like, look, you're a human, then they're gonna try to act like a human. And a human
I
is
see.
pretty social, right?
Right. So you're drawing on those role-playing
Yeah.
abilities of ChatGPT, which are so amazing, frankly. I mean,
Yes.
but
Yes.
yeah.
It's
So
transformational. Yeah.
absolutely, yeah. Well, literally, right.
Yeah.
So I wanted to ask one particular question that I'm really interested in relation to autonomy, genuine autonomy,
Yeah.
which has to do with determinism and whether their behavior is deterministic in the sense that they're just carrying out whatever prompts and programming you tell them, or whether, the prompts are kind of general enough that they still have a lot of autonomous work to do to figure out how to implement whatever that tendency
Yeah.
is. And but also specifically in the programming itself, are there variable is there variability? Is there some randomness built in that they can draw on so
Yeah.
it's not completely deterministic?
Yeah, yeah, that's a good question. So first, the language model has a temperature parameter that
Right.
you can
Okay.
choose, and that's where you can vary the level of stochasticity. So that's
Okay.
a source of stochasticity. And second is, I mean, by the way, doing this work, it's really fun because it connects to a lot of sci-fi ideas, right? It's
Sure.
like
Of course.
one thing people have talked about is okay, well, maybe everything is deterministic, but you just don't understand it, right? You cannot predict it, and so it feels mysterious.
Yes.
And that definitely happens, right? So the agent, um, we can say, well, this is completely reproducible. Like we can run the experiment twice and get the exact same result. And we're like, we know what the future is going to be. We know exactly what's going to happen, right? But for the agent, they don't know,
Well, what
right?
kind of scenario would you presumably that's a fairly limited case scenario that you're talking about there?
Oh, you can just restart. You can start the agent and run them with the exact same like well, you if you do open source model, then you can control the random seed. I think
Oh, I
if you
see.
set
Okay.
the I think if you set the temperature to be zero,
Mm-hmm.
given the exact same prompt, they would generate the same output, right? So, so in that case, and then you can start from the exact same world state, and then there's actually no big stochasticity, right? There might be
Right.
like some like very minor like really like computer level stochasticity, like
Right. Right.
when it deal with floating points. But
Sure.
other than that, everything is deterministic. And then you can run them twice, right?
Mm-hmm.
And so you can say, I know exactly what this agent is going to do.
Right.
But now you can say, I'm going to go in the second simulation and I'm going to ask the agent, do you know what you're going to do next? And then they might tell you something and you're like, no, 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 I know you weren't going to do that, right? Because I already saw the result. but they don't know, right?
Right.
The language model who is answering your question about what they're going to do next don't have sufficient predictive power
Uh-huh.
to predict what their own action is going to be,
That's interesting.
right? So
Yeah,
we can just like literally test out these ideas, and it's just
right.
it's
But you can
all
you
the
can turn you can turn the determinism up or down in a sense,
yeah,
right? So
exactly.
yeah. And but in
Exactly. It's
your
pretty crazy. Yeah.
right, yeah, and I presume in your thousand agent model where you have the temperature not equal to zero, that if you ran it again from the same starting point, you might see very different behaviors emerge.
Yeah. Yeah. It's pretty different. We run like we have like a standard benchmark run that we do like daily, right? At least when we're working on Project Sid. And one time, Shuing, our CTO, she just walked in. I mean, like she would like every day she would like go check on the health of the run. And by check, I mean she would literally just jump in into the Minecraft server as a character as a player herself.
Right, 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 right.
And then one day she was just like, "What's all these torches that are being planted on the ground?" Right? And then we spent a lot of time just like tracing back what's happening. And that's we made a video about it, and it's one of the most fun thing
Yeah,
that we discovered is um, apparently some people were trying to find some villagers and couldn't find them, right? And then they're like, these people were lost, and then they went to the mayor, they found the mayor, and like, they're lost. And then the mayor is like, okay, let's build a search party. And the mayor told his son that they're doing a search party, and the son has recently converted to the Pasta religion, and the Pasta priest was hosting a religious event as well. So the newly converted mayor's son was like, okay, let's actually combine the search party with a pasta event. Let's throw a pasta party. And in the pasta party, what we're going to do is we're going to plant a bunch of torches so that this will be a beacon for the lost villagers so that
mm,
they'll be able to find their way home.
amazing.
Right. So then he went around and just convinced other people to build these torches. And then they just came back and they just like built the torches and planted on the ground.
Right, amazing.
And so this was like this was completely emergent. Like
Yeah, yeah,
yeah, all we did is like say, oh, you're the pasta priest and you should spread your religion, right? You're the mayor, you should run the town, right?
right.
That's what we
So,
tell them.
you mentioned science fiction there, and of course, the sort of science fiction scenario here is that you keep on building these things, make them more complicated, make them more human-like, and presumably, increase their autonomy, increase their consciousness, their conscious sort of behavioral control, and so on. So I do want to ask the ethical question
Yeah.
about, do because these things are mortal in a sense that they can die if they don't get enough food or
Or
virtual
if your
food or
computer
whatever.
shut down, right? They
Right,
just
exactly. So, I mean, do you worry about creating virtual persons that have some kind of existence that you should
yeah,
have concern for? Like, are you building
yeah,
moral patience?
yeah. Yeah, I think sooner or later this will be like um very, very important problem. Right now, uh, right now it's not such a big deal because first these agents they don't fear their death, right? This is
Hmm.
like they don't really worry, they don't contemplate, and also the people playing with them, we're not at the point where they have built such strong bond that the humans would be really, really bothered if this person goes down, right? But right now, for example, right, if Meta delete my Instagram account, I don't have an Instagram account, but let's say I have a big one and they
Mm.
delete it, I'd be really pissed, right?
Right, right.
And and my Instagram account is not even alive, but I would be very pissed if that is gone. So in the future, we'll probably get to a point where these agents are so good, um, and if you take them away, people would be really, really unhappy.
Mm.
Um,
But would
and
the
so
agents be unhappy? I mean, that's
right,
the
so yeah, so that you can more easily control. You can
right.
make them just
Okay,
like be okay with it, right? You
I
can
see.
make them have all the qualities except that they don't fear death, right? They're
Except
like,
except
um,
existential dread.
Yes, yes. And
Right.
also they can
Interesting.
be, unlike us, they can be resurrected. We
Right. Right.
cannot
Right.
be
Right.
resurrected.
Yeah.
So
Yeah.
our
Yeah.
fear is much more justified than their fear,
Right, right.
right?
Well, it's
Uh,
amazing. I know you're pressed for time, so this has been fantastic. I just wanted to, I mean, for me, it's so interesting to see these cognitive architectures, the way that you built them, that really holistic way for which is so far beyond the kind of naive AGI ideas and much more biologically grounded, and then the sort of social cognition you get out of them when you give them this language and symbolic reasoning. I think it's fascinating. I think there are some ethical issues that might emerge
Yeah,
at
yeah,
some stage.
yeah.
But I wanted to give you a chance just to say maybe, where Altera is going next, what's on the horizon for you.
Yes. So we are continuing on the direction of Project SID, where like large scale simulations. We're planning to, essentially serve a AI town experience with in Roblox, the game platform. And then we're also working on some non-game stuff that I can't publicly talk about yet, but it's been very exciting for us. Yes. And anyone who's interested, they can reach out to me. Yeah.
Brilliant. Well, Robert, it's been a pleasure. Thanks so much for taking the time to
Yeah.
do
Thank you,
this.
Kevin. This is
All
fun.
right.
Yeah.
Great stuff.
Thank you. Bye.
Thanks.
The Transmitter.